Hey guys, welcome back to Coding Matrix. In this lesson, we will be going over how to use NumPy's random submodule. In the previous video, Hamad went over some more basics of NumPy, so if you haven't watched it yet, there will be a link in the description, so make sure to go check it out. So without wasting any more time, let's jump right into the video. You might be familiar with Python's random module. It's fine if you're not, but similar to Python, NumPy has its own submodule to generate random numbers. But let's just say we want to generate some random integers, then we can just use the function np.random to generate some. This function takes in a single required argument, but this argument depends on another argument which is called high. If high is set to none, then the required argument represents the upper end of the range, and if it is set to a value, then the required argument represents the lower end of the range, while the high argument represents the upper end of the range. And finally, the size keyword sets the size of the output array. So the first number in the size basically specifies the number of dimensions in the array, and the second number specifies the amount of values contained in each dimension. So in this example, since the lower end is 2, then the generated number is going to be higher than 2. Since the high keyword is set to 6, then the generated number will be under 6. And since the first number in the size argument is 2, then the number of dimensions in the generated array will be 2. And since the second number is also 2, then each dimension is going to contain 2 values. So to show how random integers can be generated using NumPy, I'm going to quickly make a random array filled with random integers. So I'm going to use np.random.randint and then set the lower end of the range to 2 and set the higher end of the range with the high keyword argument and set it to 5. And just remember that 5 is exclusive, so 5 will never be in the output array. And I'm going to set size to equal 2 by 2. And then finally, I'm going to use a print and represent function to view my array. So when I run this array, as you can see, we get a random array generated with integers between 2 and 5, but not including 5. And no matter how many times you run this array, as you can see, you will never get 5 as an output. So now, let's see what happens if we set the high keyword argument to none. So I'm going to create a new variable called noHigh and set it equal to np.random.randint with the upper end of the range set to 5, since we're going to be setting the high keyword argument to none. And now I'm going to specify the size as 2 by 2, just like before. And then I'm going to use the print function and the represent function to view my array as always. And then run my code cell. And as you can see, the output is a random array with values between 0 and 4. And 0 is also included, and 5 would be exclusive, just like before. So now, the next thing I want to talk about is NumPy's utility functions. So NumPy actually has quite a few utility functions, but the most common ones for the np.random module is the np.random.seed and np.random.shuffle utilities. These utilities allow us to control the output of these random functions. The np.random.seed utility takes in a single integer argument and is used to set a random seed. I won't go too in-depth in seeds, but consider this weird analogy. Seeds in NumPy are similar to the use of seeds in Minecraft. If you use the same seed from one world in Minecraft to generate a new world, the same exact world would be created. This is pretty similar to NumPy. If you recall the same seed to generate new numbers, then the new generated number would be in the same sequence as the old generated number from the same seed. This works because random numbers that computers generate aren't so random, but instead are numbers that are generated using a specific algorithm. These numbers are called pseudo-generated numbers. So if the same seed is used again to generate more numbers, then the computer will input the same seed value into the algorithm, therefore returning the same output. Random seeds are understood better when seen through code. So to show how the np.random.seed function works in NumPy, I'm going to quickly generate a new random seed with that function. So np.random.seed, and then I'm going to pass in an integer value, which is its argument. So I'm going to pass in 1 this time. And I'm going to use a print function and np.random.randint to generate a random integer between 0 and 5. And I set the value upper end of the range to 6 because 6 would be exclusive, so the values that are outputted would be between 0 and 5. So I'm just going to run this code cell. And as you can see, we get 5, which is a random value between 0 and 5. And I'm going to set another seed value with np.random.seed and pass in 2 this time for the seed value. And use a print function, np.random.randint. And then pass in 6 again for the upper end of the range. So we get a random value between 0 and 5. So this time if I run the code cell, I get 0. And you might be saying, Shahid, this is another value between 0 and 5, so what's so special about the seed function? So if I use the same seed again to generate a random number, so if I use this first seed, which is 1, and I use the print function, np.random.randint, and pass in the same value, 6 again, which is the upper end of the range, I'm gonna get 5 again. And this happens because the computer is basically inputting 1 as the same into the pseudo number generator, and we're getting the same output value, just like mentioned before. Now I'm going to talk about the shuffle utility function in NumPy. And this function is actually very simple to use. What this function allows us to do is randomly shuffle an array, and remember that shuffling doesn't actually have to have a return value. And shuffling multi-dimensional arrays only shuffles the first dimension, and the only required argument for this function is the array that you want to shuffle. So to show how the shuffle utility function works in NumPy, I'm going to quickly create a random array and then shuffle that array to show you the effect of shuffling arrays with the shuffle utility function. So I'm going to quickly create a random array, and I'm going to call this random array random r, and then use the np.random.randint function and create a random array. I'm going to set the lower end of the range to 1, and I'm going to set the high keyword to 7, so I'm basically setting the upper end of the range to 7, but then 7 is exclusive, so then range will be between 1 to 6, and then finally set the size keyword argument to 2 by, let's just say 3. And then now I'm going to use a print and represent function to print out random r. So now as you can see, we get this random array with integers between 1 to 6. And then now I'm going to open a new code cell, and then I'm going to call the np.random.shuffle function and then pass in random array as its argument. Finally, I'm going to use the print and represent function to view random array again to see what the effect of shuffling looks like on it. So now here it didn't really do anything, but if I keep shuffling again, as you can see here, it just shuffled the rows of the array. So it just basically switched 2 and 1 with 5 and 5. That's basically what it does. It basically switches and mixes up the rows of the array. It doesn't shuffle through dimensions, which I mentioned before. Anyways guys, that wraps up this video. If you did enjoy, please hit that like button. If you have any questions, drop them in the comment section below, and help us out by hitting that subscribe button. The collab for this video will be linked in the description below, so make sure to go check it out, and I will see you next time on Coding Matrix.